So let's look at an example finding the depth using volume and pressure. A diver is descending from the surface with a bag filled with 8 cubic inches of air. What depth would the diver need to reach in order for the air in the bag to be compressed to 2 cubic inches? Okay, so now we have two volumes, 8 cubic inches and 2 cubic inches. We want to know what depth it would take for that compression to happen. We know as we go deeper, pressure increases and the volume inside of this bag will decrease. So again, we can use the general gas law, which states that the pressure times volume over temperature equals pressure times volume over temperature. In this example, we're not giving any information on temperature, so for our purposes, we will just assume the temperature stays the same from the surface to whatever depth we're at. There's no difference in temperature there. They'll just cancel out on both sides, so we're only worried about the numerators here. So pressure at the surface is 1 atmosphere. Pressure at depth, we don't know. We've got to figure that out before we can find the depth. Volume at the surface is 8 cubic inches, and volume at depth is 2 cubic inches. So we have information there. We have 4 variables in the calculation. We know 3 of those, so we can find that 4th. This will give us 1 atmosphere times 8 cubic inches equals pressure at depth times 2 cubic inches. So we match it up. On the left-hand side, I have surface values. On the right-hand side, I have it at depth. To get that pressure alone, which is what we want to do, the pressure depth, I'm going to move the 2 cubic inches to the other side. To do that, I need to use division. So we'll multiply the left-hand side, divide by 2 cubic inches. That gives me 8 cubic inches times atmosphere over 2 cubic inches equals the pressure at depth. If you notice, I have cubic inches in the numerator, cubic inches in the denominator. Those are just going to cancel out. That's good. Pressure should be in atmospheres, and we're only going to have atmospheres remaining. So 8 over 2 is 4. That's going to give me the pressure at depth is 4 atmospheres. Great, so we know pressure 2 now, pressure depth. But I need to know the depth. So we know how to find depth already. We're going to have the pressure depth, which is 4, equals depth over 33 feet plus 1 atmosphere. I need to move that atmosphere on the right-hand side to the other side first before I can get rid of this denominator and everything. So we're just using some basic algebra here. I'm going to subtract 1 from each side, which will give me 3 atmospheres equals depth over 33 feet. We're almost there. I need to get that depth alone now. To do that, I want to multiply the denominator to the other side. So I'm going to get 3 atmospheres times 33 feet equals depth. I'm going to get 99 feet. And there we go. We need to reach a depth of 99 feet for the air in the bag to be compressed to 2 cubic inches.